Hello everyone. Today our third meeting with Jeff Tantsura. We will be discussing again many topics. Let me very fast show you what exactly we will be discussing. First thing will be SD-WAN and will we replace MPLS service when SD-WAN comes. Now it's very popular, as you might know. We will be discussing that, and after that we will discuss whether we should use multiple ASN, multiple autonomous system, or single AS for the large scale, not maybe tier 1 operator, but large scale networks. Should we do that? And after that, standardization status of the SD-WAN. Now, Metro Ethernet Forum, as you might know, have architecture for the SD-WAN, and Jeff will explain what's happening in IETF for the software-defined wide area networks. And after that, EVPN plus VXLAN, these are the questions, discussion topic that people asked us. Can you explain those points? So this came up, I think, from the network engineering group. By the way, we have Skype group, I think around 600 people at the moment, and it's growing. You can join that by adding Skype ID, which I will share in the YouTube video description, okay, of this video's description. You will see that and you can join there. So this discussion was EVPN plus VXLAN. Will it finish? Will it kill the TRIL, transparent interconnection of lots of links? As you might know, it's a standard. And Cisco's Fabric Path, will it kill or not? We will be discussing that. And also, if we have time, maybe one or two more questions we will discuss. One of them, control plane state and data plane state. What are those things? When we say control plane state will grow, and state, when we put more states, more expensive resource usage, blah blah blah. But of course, more state come up with the some benefits. What is control plane state? What is data plane state? We will explain. And last may be BFD, bidirectional forwarding detection. There's a question when BFD is not necessary. Is there any place that we don't maybe want to use BFD or shouldn't be used somewhere? We will be discussing. Okay. As you know, with me, I have Jeff. And Jeff, for the maybe some audience who watched our session first time, can you introduce yourself?
Hey guys, pleasure to be here. Thanks, Orhan. So I'm Jeff. I've been working for Apstra, the pioneer of intent-based networking. Besides, I do a lot of work in standardization. I'm the IETF. I'm the co-chair of routing working group and routing in FAT3, which is the new novel routing protocol for data centers. And I'm on AAB, which is Internet Architectural Board, the body that really governs and gives direction to IETF. So I'm doing a lot of stuff here and there. Okay. In general, I'm a network engineer at heart. I love networking, and this is what I do for life.
I am very glad to have you again. And let's start. First discussion point, SD-WAN and MPLS. What will happen?
Yeah, so as always, we take a step back and look into history. First VPN have been delivered as physical circuits or sub-circuits, being primarily ATM X25. So what made MPLS VPNs a killer app, or really MPLS with VPNs on top? Its ability to replace really rigid, complex network architecture by something that's much more flexible and much more logical, right? So you could have many, many different customers terminating on single P router. MPLS is very, very efficient way to provide segmentation and to provide common transport to all those different customers. So that's how we've seen proliferation of L3 VPNs, L2 VPNs that provide bridging to VPLS and all the stuff. So it's very, very flexible architecture that really made vendors and service providers billions of dollars over the years, right? However, what happened, as usual, let me think how to phrase it better. Bureaucracy took its place, and suddenly amount of time needed to provision an MPLS circuit started to become really unviable, like 6 months to get, I don't know, AT&T or similar service. So I would say the first generation of SD-WAN solution was primarily to solve this issue. It was classical over-the-top service. You just deploy it on premises on your offices. So rather than waiting for your service provider to give you a circuit, you'll just use your internet connection and have over-the-top tunneling being IPSec, VXLAN and IPSec, anything else in IPSec, and centralized management, which is again you couldn't get from your classical service provider. So the first wave of SD-WAN was really driven by necessity and ability to get services in time. So it wasn't technological. It was really business to solve this problem. Pure connectivity.
Okay, let me add a couple things here. For the SD-WAN and MPLS, when we discuss those, guys, please be aware that still service provider internal infrastructure will stay MPLS. There is no problem with the MPLS there. And what Jeff in the beginning was explaining, today most common application or use case or service of MPLS is VPN. So layer 2 or layer 3 VPN, Ethernet over MPLS, point-to-point MPLS, VPNs, VPLS or L3 VPN, etc. with the MPLS, and transport of the service provider will stay as MPLS. What we are discussing at the moment is, let's say, enterprise network. By the way, let's mute, guys.
I think this is Edgar.
That's the point that generally I don't want to get the live attendees.
So okay. Thank you so much for this clarification.
So yeah,
what we're talking about
exactly.
is MPLS service. It's not MPLS transport. MPLS transport is there. It's a perfect and great technology that's going to be there for a very long time. It's not going to disappear. In cases where you need traffic engineering, in cases where you really use MPLS as the transport, it's a great technology. It's not going away. What we were describing is really services that are running on top of MPLS. So L3 VPN, for example, it uses MPLS label to provide segmentation, right? So this is the connection from MPLS as encapsulation to services on top of MPLS.
So which means actually when we say that enterprise still with the SD-WAN, let's say even if they have redundancy like 2-3 physical circuit and just let's say they are receiving internet service from maybe different providers, still those internet traffic over the service provider network might be delivered via MPLS transport. What we are saying, that's important to understand. Okay,
in most cases
yeah,
they are.
Yeah.
So what we just discussed was the first wave of SD-WAN, which was overlay to address administrative challenges. So inability to get connectivity in time, and even if you get it, you still need to secure it. You need to build an overlay anyway. So pretty much any company that does VPNs at scale would build something IPSec overlay, which has its own complexity.
And so as you said, for the security purpose, they are deploying IPSec or maybe any other layer 2 security mechanism, MPLS, etc. But also for the value-added services, like when the customer enterprise looks for IPv6 service, for example, and if service provider is not providing via their L3 VPN service IPv6, they again need overlay. Or if enterprise looks for multicast, let's say, and service provider is not providing that, they will need overlay. So overlay was necessary, as you said. Please go ahead.
Yes. So, and this is nothing really new. There's a number of, they weren't called SD-WAN before. There's a number of companies that have been on the market 10 plus years doing exactly SD-WAN. It wasn't marketed right. It wasn't the right time for them. People like Ariyaka, I think some others, they've been around for a long time. So, connectivity. When something that I call SD-WAN 2.0, and it's also something I tried to define at Nuance when I was there, came around, we started looking into unification of policies and value-added services, which have very little to do with connectivity as such. Think about WAN optimization, firewalls, as you know, we are moving from centralized firewalling, which doesn't really protect you anymore, to more distributed firewall solutions. So much better recovery of errors.
And probably for the application traffic. Sorry,
I would say.
Go ahead.
So people like Zscalers providing connectivity, people like VeloCloud providing connectivity to SaaS. So, for example, if you want to go to Office, they'll figure out on your behalf that you want to go to an Azure location or Microsoft location and route you to their own appliance that's collocated somewhere at Equinix or very close by. So as you could see, there's more and more services that are SD-WAN related, but not really transport. They're really adding value to your experience and making service as such much more effective. So, and I think this is where the real value of SD-WAN is, and this is what's taking over significantly just basic connectivity, because now you're looking at whole stack up to layer 7 really, right? While your L3 VPN just gave you basic connectivity from one place to another. So this part is being developed. We see more and more unique solutions coming from different vendors, and they're not necessarily replacing L3 VPNs. I mean, in many cases they did, but what they focus on is on user experience, on additional value services, and in most cases, really connectivity to the cloud. How they're connected to the cloud in most effective way, in a way that user doesn't even know that I've taken one password to another, I got connected to one location versus another. So there's more and more, I would say, capital expenses on vendor side to build a solution, to pre-build their own POP, to provide some parts of their own transport. And this is where you really see the differentiation between different vendors.
That's right. Another
interesting part is opportunity for cable providers. Because as you know, people like Comcast in US and other cable providers, traditionally they couldn't provide B2B or business-to-business service. They were only providing internet connectivity to people, to consumers and customers. With SD-WAN, suddenly they could provide business-alike connectivity, and this is what you see in Comcast, in of other people who build SD-WAN as a platform, which is part of their services, and now they can deliver together with classical business-to-business providers, AT&T, CenturyLink. They provide similar connectivity, and it's a huge deal. There's a lot of money, and suddenly they can compete with the B2B market that was closed for them. So this drives a lot of SD-WAN deployments as well, which is another type. It's not something you buy and deploy. You go to your traditional service providers, and they do it for you. They manage it for you. So you get it as a service.
Yeah, actually, MEF came up with the architecture of that one as well. Managed service SD-WAN, when the service provider, they have their portal for the customer has their access as well. And there was a couple points here. It seems that only this point requires a separate session, to be honest, because I have a lot of things to add what exactly you said. Like firewall deployment, you talked about centralized to distributed. We are seeing, because not only protection-wise, but also for the application traffic, the latency will increase when you have centralized firewall location. If you want to do some service stitching, etc., it will be even increasing the stretch, increasing the latency a lot. Other couple things like you said, classical MPLS L3 VPN would provide the reachability mainly for IPv4. It could be IPv6 as well, but mainly for IPv4. But SD-WAN come up with the overlay, and that overlay gives you those value-added services such as V6 connectivity, such as multicast, etc. Though, when we look at the different SD-WAN vendors, the multicast might be a problem though. So different vendor may be supporting, they support differently, maybe head-end replication, maybe natively, blah, blah, blah. So probably some points should be checked. I think we should move on to second topic. But
just give me one more
minute. Sure.
I'll explain some other things. So I think what we are going to see is really the combination of SD-WAN plus transport. So today, SD-WAN is pure overlay. However, nothing prevents you of signaling to service provider network your class of service, if you're willing to pay for better service, if you're willing to pay for guarantees. What we are going to see is really two evolving solutions. One is management plane. So you have SD-WAN controller talking to one controller and requesting a path that meets particular constraints. So management plane, exchange, and it's pure business. On another side, you will see data and control plane exchanges, mostly based on segment routing, because nothing prevents you of putting particular seed or label or SRH that would be resolved by the service provider as request for particular service. And if you have right agreement in place, billing set for particular services, nothing prevents you as a customer saying, I'm going to mark my packets in a particular way, and from 6 to 8, they're going to get better service than from 12 to 2. So I think we are going to start seeing this kind of combination of two different technologies merging into single service and provide really a lot of value. So now you don't need LTVPN that has some guarantees because you also buy it with some dedicated bandwidth. Now you can signal it in line and pretty much on demand, because that's what people want. They want stuff on demand. They want to be able to buy when they need it, but not to pay when they don't.
But
so
this point,
bringing it into data and control plane, practically now you are enabled to do this.
But this point, actually, I remember two different drafts. Exactly, you are talking those drafts, I think. They are not RFC yet. And I think I wrote also an article for that. But the point is, for this one, you need the interaction between the SD-WAN controller and the SDN controller in the transport network. So probably it would be easier for the SDN controller in the service provider to have this kind of extension, but how you would actually do this one on the SD-WAN controller, I'm not sure about that. I mean, it requires a lot of effort, I think, because number of nodes, number of SD-WAN controllers, I believe would be much more than SDN controllers, because number of edge networks are much more than service provider networks. So I'm talking about scale. I am talking about the number of devices here that SD-WAN vendors also should come up with this kind of extension. What do you think? Would it work?
So if you look at transport controller, in most cases you'll have one controller that's clustered to provide resiliency and high reliability, right? But no matter to whom you talk in the cluster, they all have full view of the network, because the job of the controller is to provision end-to-end paths with different constraints. On another side, we just published a draft in routing working group that defines new architecture called NFIX, which stands for Network Function Interconnect, that describes exactly this architecture, with the only difference that the controller that talks to transport is not SD-WAN, it's actually data center, and it uses segment routing to provide end-to-end connectivity, but also traffic engineering, also trying to meet all the constraints, trying to request a path if needed to use one that's available. I'll provide the link to the draft. Actually very interesting.
Constraints such as SRLG, etc. you are talking about, I think. Pet diversity.
So.
Yeah.
The beautiful thing about segment routing, or in this case we use MPLS actually, that it could be encapsulated in IPUDP, RFC 7520, I believe. So in data center where people don't deploy MPLS, what you could do is just encapsulate your MPLS traffic into IPUDP without their destination address being segment routing router. So in data center here, DC gateway. DC gateway will see that this is an MPLS in IPUDP packet based on the destination port. It will remove IPUDP, and then the first label that you will see in this stack is bseed. The binding seed is the concept of a seed that could be resolved into another path. So in this case, the BC had been communicated by one controller and it described traffic engineering path. So when BC gateway receives this packet and looks up binding seed, it has already traffic engineered path instantiated for this particular binding seed. So suddenly you have signal from the endpoint, which is your compute node, it's not even a switch, whole path throughout the network, throughout the WAN to the next data center. So I believe something very similar can and will be done for SD-WAN, and I'll share the link to the draft, so read it, and questions are very welcome.
Okay, let's move on to the second question, which is having multiple ASN versus single ASN for the large-scale network. If we can give an example from Tier 1 operator, that would be even better. So large-scale network, multiple versus single ASN. Let's discuss this.
So having more than one ASN creates additional complexity. We do understand you need to manage more. Why would you deploy more than one AS? So mergers and acquisitions is a very natural case where companies merge. You have registered AS, you have all the relationships with your peering partners, and usually you'll end up kind of arguing whose AS is more important, right? Another case, I would say it's more historical case where people deployed configurations. So for example, when I did network engineering for UPC, we had a huge network that had many ASNs in configuration. Why? Because Liberty Global is international company, so we were buying POPs in different countries, integrating them into global backbone, and then the relationship was really at configuration level. So why would you do this? When you need different policies per particular domain. Because if you run IBGP, so single ASN, your policies are not really in the BGP. You will try to do something with IGP. The set of attributes and ways you can influence how traffic goes is quite different.
Quite limited,
EBGP,
let's say.
Yes, and different. EBGP provides built-in capabilities for policies for traffic engineering. So if you need more than one domain that has different set of rules, and it's mostly business outcomes, it's not necessarily technology. In this case, it would absolutely make sense to use EBGP relationship between different parts of your company. So I think people are not really using configurations anymore. What you could see is really after merger, people keeping their ISNs and just doing the way they did before. So every part of the company is still keeping their own ISN, peering with external people, and internally there's good agreement on the way policies are set. So there's no contradiction within the company. So policies are well understood and set centrally. But from a external point of view, they still look like two different companies.
Let me add a couple points here. Yeah, some networks, they are using confederation. That I am aware in real life. I think they are the biggest African operator, by the way. More than 20 countries they have an operation. They have per country unique ASN, and most of those, as you said, those ASN came from their acquisition in different countries, and they didn't basically change the AS number. And network has been growing, and as I said, now more than 20 countries and totally rely on BGP confederation. Of course, I see a couple of some weird confederation deployments as well, like in a very small national service provider in again Middle East country, and I think six routers only, BGP speaking routers I am talking, and 3 different ASNs they are using. When I talk with them why you are using this, because compared to full mesh IBGP or route reflection, this is better for troubleshooting for us, they said. Different reasons. And merger acquisition, you gave an example. Plus, this kind of maybe troubleshooting is easier for them because, as you said, this is EBGP relation. Though most of the rules when you use confederation, EBGP works like an IBGP. We call it intra-confederation EBGP, and like next hop, etc. Is sent but many attributes are not changed there when we use confederation. Also, acquisition you said, I remember before level 3 acquired by CenturyLink, they had 13 different ASNs, and they were from the ASCon point of view, they were the biggest tier 1 as I remember. So number of ASN and their customer ASN, etc. ASCon point of view, they were the biggest tier 1. And they had more than 10, as I remember, 13 different AS numbers. And you said complexity. And what I believe in network design, always trade-offs, always there are good things and bad things. Complexity, we consider sometimes bad thing, though it's necessary, but unnecessary complexity, bad thing. What would be the advantage when we say, okay, we talked about use cases, confederation and merger acquisition, and maybe ease of troubleshooting for some people. But you said complexity and people consider complexity as bad. What would be the advantage of having multiple ASN? You said one thing actually there, having separate policy domain. This is very important for if you guys want to understand more, we can elaborate. What else would be, do you think? So if we would say advantage point, maybe traffic engineering point of view, what do you think?
So, simplest solution would be to deploy IBGP with router reflectors, right? This works, proven. What you're getting is a single domain that behaves as a single domain towards external peers. You would deploy multi-AS scenario based on either business, not business, I would say more historical events such as merger and acquisition and unwillingness or inability of people in different ASNs to merge. It becomes very often political issue. If we take your ASN, probably we are out of job, right? So you might see different ISS, which is not has nothing to do with technology. It's just politics.
Now,
on another side,
very important here. Very important here when you said politics. Let me give you an example, and please tell your point here. When we look at the service provider, especially those multi-service service provider, like they are providing fixed and maybe mobile service as well. What we see in their mobile packet core is different ASN, their MPLS core different ASN, probably their IGW layer, internet gateway layer different ASN, and maybe their worldwide connectivity, like in different countries, different IXPs, etc., different ASN. I am seeing this multiple ASN in the same company in this way as well for different pins, different place in the networks. So do you think this one is political as well? What do you think?
So don't forget that the assumption of IBGP is a common IGP. So imagine you run different IGPs, you have again religious view about OSPF versus SS versus IGRP. So suddenly, if you go to IBGP, you also need to decide which IGP are you going to use. Are you going to redistribute? I mean, there's a lot of religious discussion, and I've been through this. So sometimes keeping your own domain, providing clean NNI, which is really EBGP, is much more simpler from organization perspective than trying to merge 6 different IGPs and 6 different ASNs into single one. And God forbid you start redistributing IGP into BGP and back, because this is the only way to merge them. You will forget someone that you are doing this mutual redistribution. You'll create loops at scale. You have seen this many times. And someone will come and tell you, you know what, just keep your EBGP and we will be talking EBGP to each other. We are friends, but not family.
Yeah, that's a good point. So, but again, you probably seen as well this mobile networks and their IP MPLS core, and most of the time even internet gateway layers. At least 3 different ASN I've seen in many networks, and maybe job security, like different group they have their different ASN, etc.
Managed by different people in different ways, different practices, different tooling. So it's much easier to keep NNI and this clean relationship on EBGP levels and try to complete it.
And yes, I would come. I would
associated with merge is often outweighs benefits, at least short term.
Exactly, but now complexity appears there. when especially they want to carry IP reachability between those domains, they have to interact with the inter-AS VPN type of deployments. I've seen that one as well. They are saying, I have, inter-AS MPLS option C in my network, not with the different operator, etc. Why? Most of the time comes up with this answer, because I am using mobile packet core. My ASN is different than my IP MPLS core. Then when they want to extend their L3 VPN, they need to deal with the
as you could see, for most reasons, or most significant reasons, it's really non-technological. It's business or pure politics. So it really depends on the structure of the company and understanding of long-term goals. Because long-term integration should bring savings, better management, better understanding of how the network behaves, and then short-term, there's additional cost of integration, retraining people. Actually, there's some redundancy in people, so someone most probably will lose their jobs. So very little to do with technology.
But that's an important point as well.
Structure.
Yeah, when you try to merge those, so you will be looking from IP MPLS guys, at least some mobile knowledge, and vice versa, or some people who have already experienced, they will stay in the company, and some people might lose their job. And this generally happens, especially when they use internet gateway layer and IP MPLS core, different ASN, but they want to merge those two ASN, and then same engineers now, not different groups, but same engineers manage both part of the networks. We've seen this a lot of time, not much mobile and then IP MPLS guy merging. It might be happening, but in real life I haven't seen. Anyway, any other points?
From a technology perspective, there's one more point, namely traffic engineering. It's really, really complex to do traffic engineering in multi-AS. It is already complex to do it in multi-area, multi-level. If you add multi-AS on top of this, you need to build right level of abstraction, the controller that sees entire path and probably only entry and exit points in different ASMs. So there's a very serious consideration if you are planning to do traffic engineering, actually trying to converge to have someone has full end-to-end view of all your networks, not just different ASMs trying to stitch them together. This is really complex thing to do.
Yeah, what he said, let me try to make it a little bit more understandable. So even multi-area traffic engineering, he said, it's hard to solve. You need a controller. The idea is because we are talking about optimal routing, and optimal routing generally for us is using shortest path. Of course, your optimality may not be shortest path, maybe low delay or cheapest link, etc. But optimal routing. And for us to send the traffic through optimal routing or shortest path, you need to know entire topology. So if you are talking about single IGP domain, it's easier problem to solve because every node knows the topology. But when you have multi-domain IGP even, I'm not talking different ASNs, single ASN, but different areas, different levels, let's say, IGP-wise. Now some extra things you need to have, such as maybe controller or loose-up extension, we have some solution to have. So end-to-end optimal routing you can have. And now already this is hard thing, or you need some workaround, or you need some extra layer of complexity because extra technologies needs to be introduced. If you talk about inter-AS traffic engineering, it can be done for sure, but it would be more expensive for us, as Jeff described. So if I just very fast summarize, single ASN versus multi-ASN, we can easily say that multi-ASN is complex and traffic engineering is hard for that. But mainly it comes after merger and acquisition, and people don't want to change the ASN. Changing ASN, even we have an RFC for that, how it should be done, etc. Local AS, private AS, some features are explained in that RFC. We are not going that now. We are not talking about that, but having single ASN is easy to manage, easy to do traffic engineering, simpler approach. On the other side, you have a single domain there, which means if you want to have different policy, let's say multinational operation, we are talking about different countries. If you want to have per country different operation, in Turkey, some people know ISAS. In United States, they don't know ISAS or SPF. Let's say you in the single network, single ASN deployment, we have single IGP as well. But when we have confederation type of deployment, multi ASN, in every separate ASN, we can have different IGPs also. And this kind of different policies can be done as well. I think it was also nice and enough discussion to explain this point. Third point, Jeff.
So rule of thumb, keep it simple unless you need to do it otherwise.
Okay, excellent. Standardization status of SD-WAN. What's happening in IETF?
So there's a single draft that actually was published about 2 years ago by people participated in ONUC, which is another user group. It defines open SD-WAN exchange. So really how different controllers can interact with each other in a way. So imagine you're a company have deployed one vendor on one side, another vendor on another side. How do they interact with each other? So this draft that has unfortunately expired defines this data model or service data model, which information is important, how these two controllers are going to interact with each other. Actually, it's pretty much defined as this technology, the MPLS interest option A and B in this case, and provides layer of API because every data model is a set of APIs towards multi-domain controller to program multi-vendor, multi-SD-WAN controller infrastructure to behave the same way. So it's very early work. Unfortunately, expired. I'm not sure what's going on there. I'm not with Noash anymore, so it's not really my job to do this. But I'm being in the others, trying to work with it. On MEF side, MEF 3.0 is trying to define SD-WAN as a service, how SD-WAN controllers are interacting with each other, as well how to integrate it into LSO, which is another framework MEF is developing, stands for Lifecycle Management and Orchestration. So how do you build this vertical stack of different services where SD-WAN makes part of, how do you integrate it, how you provide lifecycle management. So I would say talking to some large tier ones, they're interested in MEF work. Traditionally, they have been interacting with MEF, and MEF is still using the same terminology. So, for example, interface from SD-WAN to end customers and NNI. So people are familiar with it, and there is no really competition to MEF in this area. So I think MEF is really leading in this area at this point in time. So I believe there's some work in IETF happening in segment routing area. There's some work that's happening in routing working group, so the data model for services. However, there's nothing really that provides this whole picture of how to manage, how to deal with it. So at this point in time, work that's done in MEF probably is most coherent one. We'll see more because the Z1 is popular, so no and said, but it's early days.
But my question then, we don't expect at this moment any interoperability between the vendors then, SD-WAN vendors.
So in data plane for sure not. I mean, it will take probably 10 or so years because everyone is having some magic powder on top, right? You put additional bits into IPSec, you put additional bits into VXLAN to provide some measurements. So don't expect this to interwork anytime soon. However, from data modeling perspective, the service is very similar. If it's basic connectivity, there's no difference between the Tela to Versa to VelaCloud to anyone else. It's still hub to spoke, hub and hub with some semantics, right? So this definition should and can be done pretty soon. How you manage this, again, they're managed in very similar ways. So this high layer of APIs is necessary, and I believe this is where the focus.
Okay.
today.
So it's obviously we don't expect anytime soon any RFC for the SD-WAN or SD-WAN architecture from ITF guys, as
So
Jeff
having
answered.
said that, you can still exchange reachability and some attributes over BGP. So theoretically, you could connect a controller to a controller, both would run BGP, exchange some reachability. There's actually work in ITF, which we didn't mention, called a IPSec distribution over BGP. So now when you start your SD-WAN controller, you can actually abuse BGP to distribute security attributes. So there's some work going on, and it's mostly BGP related.
Just a second. Let me understand. It's different than 5575, right? Flow spec.
Yeah. There's completely new work. I'll share the draft with you that describe how to use BGP to distribute IPSec related stuff.
Okay, excellent. We will put this, he said so far, two things actually we will be sharing. In the description of the video, you will be seeing them. Another point, actually, we have two questions, but I think because of timing, we can just discuss one. And EVPN plus VXLAN would be so long, so just let's go with the short one.
Actually, the answer here is very short.
Yeah, but let's discuss another one. I also want to talk about that because EVPN plus VXLAN we could go and we can explain in detail. I think 10-15 minutes it deserves. So that's why probably next session would be great for that. Now, question. Can you explain the differences between the control plane state and data plane state? What does control plane state mean? And what does data plane state mean? Which one is expensive for the resources?
So let's take BGP, it's our favorite protocol. So when you exchange reachability over BGP as protocol, you get some control plane state, which is route received from BGP that has number of attributes that you use then to compute a best path. So if you think of a routing stack, you will have a protocol, you'll have a place where every protocol puts its best route called tree, and then you'll have feed, that's another software structure that then populates according to information. So from amount of information, if you look, the amount of information reduces as you go top down. So in BGP, you'll have all the prefixes you have received. In RIP, you'll have only best prefix to particular destination because BGP would run best path selection and choose either single prefix or maybe with add pass more prefixes. However, in RIP, you also have comparison between different protocols. And usually, obviously, you always compare prefixes with the same length because shortest, longest prefix match always wins, independently of what protocol. Right? So given that you are talking about prefix with same length, now we are going into comparison between which protocol is better. Usually we use an attribute called administrative distance, at least in systems called different from different vendors, and the prefix that has the best administrative distance wins. So if you have 5 prefixes that are exactly the same, but one came from BGP, one from SDF, one from ISS, and one is static, you will choose one, and this only one prefix will go into feed. So feed is software structure that really mimics what you do in hardware. Also, as you go down, your BGP is in memory, so in RAM, which you have abundant today. Usually, modern router will have something like 16, 32 gigs of memory, which gives you enough capacity to keep 100 in a route. Your RIP is still in memory. However, it's more compact because, as we said, it doesn't take every route. It only takes best routes. Your forwarding plane or data plane state is instantiated on the ASIC. So ASIC typically has less memory. Even so, if you look at modern ASICs such as Jericho, you often see that they come with a lot of memory. What's important to understand, however, not of all this memory could be used for routing only. You've got MAC addresses in a VPN, you've got MPLS, but you've got a lot of stuff that's shared. So the memory on the ASIC itself is the most precious resource. What's important to understand also, you've got different levels, like on CPU, there's L1 cache, L2 cache, L3 cache, and so forth. So it takes different amount of time, different number of cycles to get to particular level. ASICs are no different. So if you look at the cache that's the closest to the processor itself, it's usually in megabytes, right? If not in kilobytes still. This is where you put prefixes that are being forwarded because you want to be able to look them up as fast as possible. As you go higher in the cache levels, you start putting stuff that could potentially be asked, but not necessarily. And then you have everything else. So you don't necessarily forward traffic to all the destinations, but you still have all of them in this memory that's less expensive and takes more time to access. So there's like hierarchy of 2 or 3, sometimes more levels in the ASIC. So the deeper you go, closer to the ASIC, the more expensive your resources are. The state of data plan in general is what should be using for forwarding. Usually the prefix itself, adjacency you would be using, potentially label, potentially next hop, and some additional metadata. So it's very, very optimized structure, usually written in reasonably low level language. Most of the stuff is still written in C. If you go into control plane, and you'll have whole structures for BGP, your memory is in gigs, so you keep a lot of stuff. You keep actually as much stuff as you can in order to provide most optimized route to the end destination. And as you go down, as we said, you reduce the amount of information, you compress, and then some ASIC actually that don't do recursive over recursive lookups, you would need to compress all this information into very simple data structure that ASIC can consume. So as we said, control plane state is all your routes on protocol level, all your best routes on the RIP level. Data plane state is what you use for forwarding, plus attributes that you need really. So MAC, MPLS label, adjacency ID. So very, very optimized, very, very memory optimized structure.
When you said attribute, you are not talking BGP attributes, etc.
Oh, no. So BGP attributes is only relevant to BGP, right? So you will use BGP attribute to define best BGP route. When you get into RIP, it's not really relevant. You might keep it for some reasons when you do distribution, some other things, but practically BGP attributes are only relevant to BGP. OSPF attributes are only relevant to OSPF. As you get into basic route selection, what's going to be put into forwarding state, those attributes become relevant.
So what we are saying so far is routing protocols, let's say, not only routing protocol, by the way, create control plane state, right? Let's say that one as well. So whenever we have control plane protocol and some learning happening between the devices, we are actually learning, we are exchanging control plane states. So when we get through BGP, IGP, many IGPs might be, they have their own memory structures. So BGP own routing table, or SPF routing table, etc. Yeah, GRP, whatever routing table. And then those are all control plane states. Those routes, let's say for the same prefix, if it's received via multiple routing protocol, including BGP, they will all compete to be in the RIP, so device CPU. And they are also in the RIP, routing information base, they are still control plane state. But the only one of them, if of course longest match, let's say /24, comes from the best admin distance, but /25 worst admin distance, still /25 will win longest match. And whatever wins, it will be placed in the FIP, forwarding information base, and it will be data plane state. So individual routing protocols plus RIP, routing information base, we call what? Control plane state, but for the data plane state, basically whatever we have in FIP, right? So with that, let's finish, in fact, and I think we might have some memory issue as well. So let's finish here.
Comment here, not all information that's in type coming from RIP. So if you get a prefix from RIP, it needs to be augmented by MAC address that your next hop is using. It might need to be augmented by a label that you are going to push. It might need to be augmented by some other encapsulation that you're using. So this information might come from places like Label Manager, like BridgeD, like some other components in the system. So it's really a composite of all the data you need in order to send packet to your neighbor.
Okay, so today we talked about these points, but we have many other points. We will have next session probably in a week or 2 weeks time frame with Jeff. We will be answering your question. Jeff, what would you like to say as a last point?
Thanks everyone for your time. It's always a pleasure. I'm looking forward to your questions. So Orhan is publishing this on LinkedIn and Twitter. Please publish your questions. We'll try to address them as best as we can. We will be inviting other people. So Job, Kiyur, Dino are on the list. So we'll try to keep it interesting for you. And thank you.
Exactly. Also, please, guys, both Jeff Tantsura, Orhan Ergun, we are using heavily LinkedIn, so you can find us on LinkedIn. You can connect us. If you have questions, please, under the post on YouTube channel or LinkedIn, you can ask us. We can discuss there. Thanks for all attendees, by the way.